We will be working on section 5.2, page 1. Please pause your video and read the definitions, both of them, and the note, and then start the video again to do the example. Okay, we're going to work on example 6. So you know now that to be similar triangles, you're going to have the same shape. The angles are going to be congruent, but the sides are not necessarily going to be congruent. So these two triangles are congruent. It says that here. I'm sorry, not congruent, but similar. So notice that one is a smaller version of the other. That's the way you want to think about similar triangles, is one is just a smaller version of the other, or one is a bigger, stretched version of the other. Okay, so they're asking us which angle in this triangle corresponds to n. Well, it's going to be just like when we had congruent triangles. We look at the statement here. So if we want to know what corresponds to n, we say, well, it's the last one, so C would be the answer there. And these are actually congruent because we know that the angles in similar triangles are congruent from the statement above here. All right, here we're asked about which side corresponds to side AC. So here is AC. So in the picture, it looks like it should be XN, but when we look at the statement, A and C, first and third, it should be first and third here. So also XN. We want the line over the top to represent the side. Okay, here now, when we talk about the triangles be proportional or similar, we want a proportion for the sides. So we start with this first side here. I like to do the proportion as little triangle over big triangle. Just seems easiest that way. So we're going to start with side AB. And that's going to be over. Actually, we do not want a bar because we want it to represent the number. Okay, so the length of the side. So AB, what does it correspond to? TX. We're setting up a proportion, so we put equal. And what will that be equal to? Well, if we take this side, AC, it's on the little triangle, so it goes on the top. To side XN, it's on the big triangle, so it goes on the bottom. And then we're just going to keep going. You probably wouldn't set up another fraction, but you could use like the first and the third fraction. So here we're going to say side BC. It should go on in the numerator because it's from the little triangle. The bottom TN here for the big triangle. All right, so we could use any two of these to set up a proportion. Okay, and we're going to see that here in this next problem. Okay, so here we're told that triangle ABC is similar to triangle PRC. And it should look that way to you, that one is just a larger version of the other. We're told that the measure of angle A is 67 degrees, so let's mark that. Side PC is 5. Side CR is 12. And side PR is 13. And AB is 26. So that one is 26. Okay, first thing they ask us is what is the measure of angle B? Well, in this great big triangle, we know that all the angles have to add to 180. We know this one's 67, this one's 90, so we can easily figure it out by subtracting these two from 180. So we're going to say move it over here a little bit, in triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. A is 67 degrees. B we don't know, so we'll leave that as is. C is 90 degrees because it's a right angle. So we add these two and we get 157 degrees plus the measure of angle B equals 180. Then we're going to go ahead and subtract 157 from both sides. And we get that the measure of angle B is equal to 23 degrees. All right, that's the answer to A. Okay, part B now. Angle RPC. So RPC. Well, we know that these two angles are congruent because the triangles are similar. Notice here that in the statement, A corresponds to P. So since the triangles are similar, angle A is congruent to angle RPC, or their measures are equal. So we know that angle A measures 67 degrees, so that's what RPC measures as well. Okay, C now. We're asked to find side AC. Well, side AC is this piece right here. So we know that we can find those pieces of the triangle. What we need to do is set up a proportion. So we want side AC to be in that proportion. Well, right now we know all three of these pieces, okay? And we know these two in the triangle. So we know that in the proportion we'd like to have something that we know. So let's do little triangle over big triangle. And we have the two corresponding sides. So let's put 13 over 26. Then on this side, we can only have one unknown. So if we're trying to figure out this side right here, AC, that corresponds in the little triangle. That's the side in the big triangle. So let's put that down here. Well, what side would that correspond to in the little triangle? This one right here, PC. Okay, so we would write a 5 in there. Okay, so then we can go ahead and figure out what we've got by doing cross multiplication. Okay, so we have that 13 times AC going this way equals 26 times 5. Oops, sorry about that. Or 13 AC equals, I'm just gonna, you know what, I'm gonna leave it like that and do this. Let's divide both sides by 13. And then we have AC equals, do you notice here, 26 times 5 over 13? We can do a little simplification here. 13 goes into 26 2 times. So then we can see here that AC equals 2 times 5, or 10. Okay, now with part D here, we're supposed to find side CB, so this big one here on the triangle. So we have two ways. We can set up a proportion, or since we have this piece here and this piece, we could use the Pythagorean theorem. I'm going to go ahead and practice another proportion since that's what this section is about. Okay, so we know that we have this relationship 13 to 26, okay, and that's equal to, we're trying to find CB. That's the side in the big triangle, so big triangle goes in the denominator, CB. And then we want to find that corresponding side in the little triangle. We'll write here, CR. Okay, so what is that? 13 over 26 equals CR is 12 over CB. So again, we're going to cross multiply. Okay, so we go up here, and what do we have? We have 13 times CB equals 26 times 12. If we divide by 13 both sides, we get that CB equals 26 times 12 over 13. Again, do a simplification, goes in twice there, and we get CB equals 2 times 12, or 24. Okay, so notice the relationship. Notice that 13 in the small triangle, 26 in the big triangle. It's double, right? So it makes sense that if we have 12 in the small triangle, that what would we have in the big triangle? 24. Sure enough, that's what we have. Going up here, if we have 5 in the small triangle, we should have double, or 10 in the large triangle, and that's what we get. Okay, that's the end of page 1.